2.3, linear functions in slope-intercept form. So you notice we skipped 2.2. 2.2 is direct variation, and there's not a whole lot of usefulness with direct variation. If you feel I'm cheating you, we can talk and I'll teach you direct variation. So we jump into slope and slope-intercept form in 2.3. And slope is nothing more than, I'm sure you've seen it written many different ways. It's the vertical change, okay, over the horizontal change. That's all it is. So we've always seen this formula as m equals y2 minus y1 over x2 minus x1. This is the formula that we need to know to find slope, and that's when we're giving two ordered pairs. So we should be able to find the slope. And again, different things that we can call slope are rate of change, same exact thing. So rate of change in a word problem is the same exact thing as slope. So anytime I'm asking you to find the rate of change of something, I'm asking you to find the slope, which is found from this formula, y2 minus y1 over x2 minus x1. Okay, so this right here is very important. So we're going to find some slope given a couple of ordered pairs. So we're going to start off with example A here, where again, I tell students this. We're going to use this formula, m equals y2 minus y1 over x2 minus x1. Okay, I don't care what you let equal x2 and y2. You just have to make sure that you write them in a consistent manner. Someone may write it like this, y1 minus y2 over x1 minus x2. They just have to be lined up. See how that y2 and x2 are right next to each other? So in this example, I'm just going to simply label this. This is my x value. That's my y value. This is my x1. That's my y1. That's my x2. That's my y2. So I'm going to say m equals y2, which is 4, minus y1, which is 7, all over my x2, which is negative 2, minus x1, which is negative 3. Again, look how I wrote that out. And now in the formula, it's a minus, so it will always be a minus, and then whatever that number is. In this case, it becomes a minus minus, which is a plus, and I get slope as negative 3 over 1. Again, slope is rise over run, so I would like you to keep it as a fraction. Okay, so again, we just got done learning this type of notation where this is my input, that's my output. This is my input, that's my output. So if I wanted to write this as an ordered pair, it'd be the ordered pair 3, 1 and negative 4, 1. So again, that's from 2.1, just knowing how to write different ordered pairs in this notation. Okay, again, that's function notation. So if I were to do the math here, it'd be 1 minus 1, right? This is my y2, y1, and then I go 3 plus 4. Okay, let me write that out. How did I get a plus there? The formula is a 3 minus negative 4 from here, and then I just get a 0 over negative 7. Or I'm sorry, 0 over positive 7. Okay, if 0 is on the top, that means that my slope is 0. Okay, what type of line has a slope of 0? And this would be a horizontal line. Horizontal line. Okay, so if we look at example C here, same thing. I would get negative 3 minus 1 over 7 minus 7, which is negative 4 over 0. This is a no-no. We cannot have 0 in the denominator of a fraction. So this is undefined. Okay, that's undefined slope. When there's a 0, undefined. And this is always going to be a vertical line. Again, if you were asked to plot these 2 points on a number line, okay, we would go right 7, 2, 3, 4, 5, 6, 7. We would go up 1, which would be here, and we would go right 7 and then down 3 for 7, negative 3. If I were to connect those two with a line, it would give me a vertical line. So anytime you get a slope that's undefined, it's a vertical line. Anytime you get a slope that's 0, it's a horizontal line. Okay, so now we're going to start talking about linear functions and linear equations and stuff that should be very familiar to you. We're going to talk about the x-intercept and the y-intercept, okay, of a line. So does every line have a y-intercept and an x-intercept? Any line that is slanted, yes. Okay. If it's a vertical line, it will only have an x-intercept. If it's a horizontal line, it will only have a y-intercept, and we'll talk about that in a second. But here's the formula that we need to know, and you should have seen this before. This should be very familiar. Y equals mx plus b, where m is my slope and b is my y-intercept, okay, where the graph crosses the y-axis. So knowing this formula, we're going to work with this now throughout the rest of the chapter and into chapter 3. We've got to be familiar with y equals mx plus b. So this simple example number 2 says, what is an equation of a line? So I've got m equals 1 over 5, and I've got the ordered pair 0, negative 3. Okay, so there's 2 ways to do this. The first way is to just plug it right into that formula. What's my y value? It's negative 3. What's my m value? It's 1 over 5. What's my x value? It's 0. And what is b? I don't know. So I'm just plugging it into y equals mx plus b. So now I'm going to solve for b. Well, what's 1 over 5 times 0? It's 0. So I have negative 3 equals 0 plus b. So negative 3 equals b. So again, how do I write the equation? I write y equals mx. I know m is 1 over 5. X plus b. B is negative 3. So this would be the equation. Now, what I'd like you to be able to do is recognize that this ordered pair that was given is actually a y-intercept, because a y-intercept has an x value of 0, right? Anywhere that this graph crosses the y-axis, the x value will be 0. So you could have done that without showing any work at all. But if you were confused by that, then you just plug it into this formula. And again, m is always our slope. And then you have the ordered pair where this is my x value and this is my y value. And we would just plug it in. Okay, so again, what is an x-intercept? X-intercept is where the graph crosses the x-axis. And what is special about that point? The y value will always be 0. Okay, and a y-intercept is where the graph crosses the y-axis, and the x value for that will always be 0. So if I ask you to find the x-intercept and the y-intercept of an equation, okay, in order to find the x-intercept, so I want you to find the x and y intercepts. Okay, so mathematically, how do I do that? To find the x-intercept, I'm going to let y equal 0. So I'm going to have 3x minus 4 times 0 is equal to negative 12. Well, what happens when I plug in 0 here? This negative 4 times 0 is 0, and it basically just disappears. Okay, times 3 or divided by 3, and I get x is equal to negative 4. So I want you to write this as an ordered pair. I got x is negative 4. What is the y value? Again, I plugged in 0 for y, so I have the ordered pair negative 4 comma 0. Then if I ask you to find the y-intercept, we're going to let x equal 0. So again, 3 times 0 minus 4y equals negative 12. Pay attention to your signs. The 3 times 0 would cancel. That negative does not cancel, so it would be negative 4y equals negative 12. And I divide both sides by negative 4, and you get y equals 3. So this ordered pair would be the ordered pair 0, comma 3. If I asked you to graph those on a number line, I'm hoping that we remember how to plot points. Negative 4, 0 would be to the left 4, and 0, 3 would be up 3, and we would draw a straight line through those 2 points if I asked you to graph. Okay, so now the next step is to be given an equation. We put this into slope-intercept form. So I have 3x minus 4y equals negative 12. Slope-intercept form is basically saying get y by itself. There's 2 steps to doing this problem. So we did the problems back in chapter 1 where we were solving for a variable. We're doing the same thing here. We're trying to get this y by itself. So I'm going to move the x by subtracting it. Okay, negative 4y. Notice I keep the sign there is equal to, I cannot combine those, so I just simply write negative 3x minus 12. The order doesn't matter, but in slope-intercept form, the x is always first, so I'd like you to get familiar with putting that first. And then to get y by itself, I'm going to divide everything by negative 4. So I would get y equals, a negative over a negative is going to be a positive, so 3 over 4x. I'm not afraid of fractions here because this is my rise over run, okay? And then negative 12 divided by negative 4 is a positive 3. So again, if I were to graph this, what's my y-intercept? It's 3. So I would go up 3, and then from that point, this is my rise over run. So I would go up 3, and I would run 1, 2, 3, 4. So my graph would look something like this, and you'll notice that's the same exact line that I just graphed, just using slope-intercept form. Okay. So write the equation in slope-intercept form. What are the slope and y-intercept for? So for this problem, example A, it says 5x minus 4y equals 16. I want you to solve for y. So we're going to move the x by subtracting it. Negative 4y equals negative 5x plus 16. We're going to divide by negative 4. We're going to get y equals a positive 5 over 4x, because a negative divided by a negative is a positive, minus 4. So my m would be 5 over 4. My y-intercept would be negative 4. Okay. Next example, I think this is a little bit harder because it's dealing with fractions, but we still do the same thing, okay? Negative 3 over 4x plus 1/2 y equals negative 1. I'm going to add 3 over 4x because I'm moving it to the other side. So I don't care that it's a fraction. So that cancels over here, and I have a 1/2 y is equal to 3 over 4x minus 1. Notice that negative 1 stays a minus 1. And then I'm going to multiply by the reciprocal, everything by the reciprocal. Okay, so I have y equals, so that cancels, 2 times 3 over 4. If you're terrible with fractions, then you should be going to delta or going to Desmos, and you should put 2 times 3 over 4. Sure that was right. 2 times 3 over 4. Okay, 2 times 3 over 4 right here. And I get 1.5. Make it a fraction. So I get 3 over 2. So I go ahead and put in 3 over 2. Okay, 3 over 2x, that's my slope. Negative 1 times 2 is minus 2. And my slope is 3 over 2. My y-intercept is negative 2. So again, solving for y is 2 steps. Move the x term, multiply or divide by the coefficient. Okay, so then now let's talk about how to graph equations. We're going to do this one 2 different ways, and this is going to be the last example. So we're going to first graph this by finding intercepts. So 1, graph by finding x and y intercepts. Okay, so finding x and y intercepts. How do I find the intercepts? I'm going to find the y-intercept. Let x equals 0. So to find the y-intercept, I let x equal 0. So it'd be negative 2 times 0 plus y equals 1. Really simple because that cancels. Y equals 1. So I have the ordered pair 0, 1. To find the x-intercept, I'm going to let y equals 0. So I would have negative 2x plus 0 equals 1. Okay, so this cancels and gives me negative 2x equals 1. I'm going to divide by negative 2. And I would get x is equal to negative 1/2. So I'd have the ordered pair negative 1/2, 0. Okay, so how would I graph that? Okay, sloppy graph, sorry. But I'd plot the ordered pair 0, 1. I'd plot the ordered pair negative 1/2. So there's negative 1. Negative 1/2 is halfway between it. Connect the 2 dots. Try and draw a very straight line. There's my graph. If I wanted you to solve this by getting this into slope intercept form, we're getting y by itself. So the first step is to add x. Add the 2x to both sides. So that cancels, and I have y equals 2x plus 1. That's in slope intercept form. So this is my y-intercept, or what I call my starting point. So I'm going to plot that point first. Y-intercept of 1, go up 1. My slope, okay, my slope is 2 over 1. So I'm going to go up 2, right 1. There's the next point on the line. I'm going to go up 2, right 1. There's the next point on my line. I connect the dots. There's the graph. So you should be able to graph either way, slope-intercept form or finding intercepts.